Start, sir.
Yeah. I think video moment का link moment pass. So YouTube में video मूवी नहीं हो रहा है.
It's going on. I think it's coming. There is a net problem, but I think
Okay.
I can see that.
Sir, from my side, YouTube is going smoothly, but maybe from your side, network issue. So, sir, please go ahead your live session, sir.
What is that? YouTube. Yeah. Should I pause YouTube? Pause करना पड़ेगा क्या? Video moment का link.
Sir, only you can see only the chat box on your YouTube. Okay.
So YouTube में video मूवी नहीं हो रहा है.
It's going on. I think there is a net problem, but I think I can see that.
Sir, from my side, everything is going smoothly, but maybe. Sir, you are in live. You can start now, sir. Go ahead your line. And please mute the YouTube's audio, sir.
Hello. इसमें पहले पास करना पड़ेगा और वीडियो सॉरी ऑडियो भी ऑफ करना पड़ेगा ना YouTube में. हाँ ठीक. क्या स्टार्ट करना है? Okay, started. All right, welcome to the live session. This is the first live session on irrigation and drainage course, NPTEL course. So we got some the questions from few students as well as the faculty and farmer. So we're going to see one by one before there is any other question. So the first student is from Jharkhand. His name is Anand Ansda. So as such, there is no question, but it seems he wanted to join. But let me see if he has a specific question. He may type in a chat box on YouTube, and we may be knowing that. Uh, yeah, good evening, Aditya. So we will go to the chat box a little later. So there are, as I said, there are 9 responses. So the first one is a student from Jharkhand. He did not give any specific question. His name is Anand Hansdak. And the second student is Santosh K. His question, he's a student, his question was like, what are the types of irrigations suitable for each places and soils, right? So, and he said, okay, industry or message, okay, that's fine. So as we mentioned in the course, like irrigation and drainage, so the first 5 weeks, I think this is the 5th week is going on, right? So you might have come across the types of irrigations, okay, both surface as well as micro irrigation, right, pressurized irrigation systems, right? So the question is how to select a particular irrigation system, right, for a particular soil or the particular the place. Okay, so that was this question. So the soils generally, if you see, this vary from loamy soils to heavy soils, as well as sandy soils. So we already gave this information on suitability of particular irrigation for a particular soil, as well as there's other parameters also. Based on that, the criteria of selection is explained in a slide. So that is there in week 4. So basically, suppose if your area has a sandy soil, right? Sandy soil, a lot of the soil, the sand portion is larger. Okay. So what happened if you use a flood irrigation in that case, right? Flood irrigation means it requires a lot of water. So the moment you deliver water, so because the intake capacity of sandy soils is more, okay, so the water will not stay on ground, or in other words, the infiltration opportunity time may not be meeting in this case. So in that case, what happens? There is a lot of water wastage through depopulation, right? So in that case, we prefer the micro irrigation, right? Drip irrigation, or you say, the sprinklers, right? So, but if you have loamy soils to heavy soils, something like that, then probably the infiltration capacity is relatively smaller, right? Infiltration rate is relatively smaller. Then you can prefer the flood irrigation. Okay, so that's different soils, and suppose if you have different places, that's what you're saying, right? So the places. So the places where you have enough water, places where you don't have enough water, right? So that also very important. Okay. And also the place where there is availability of market, right? Like you suppose you for micro irrigation you need sophisticated components. Suppose you are living in a rural areas where there is no market accessibility, probably you may have to think about some other alternate things, okay, alternate methods. And the other thing is, am I audible? Okay, so The other thing is the energy. Okay, so for if you check the surface irrigation case, the energy required is less compared to the pressurized irrigation systems. So energy in the sense pumping cost, because that system requires pump, right? Because you have to force water from inlet to the delivery point, isn't it? So that's why you need to pump water, and pumping cost and the cost of components. So most of the cost will be involved in energy as well as the skilled labor and all other things. Okay, and the place are like a dry versus humidity, humid or warm. So different climatic zones we have. So based on that, also the irrigation system will be different. Okay, so you have like a humid region, right? Humid region, and suppose you are using the irrigation system. So that's somehow it's a good, because humid regions, so there is already moisture out there, and sprinklers anyway is space, so that's the drift. Drift could be an issue, but in this case, since it is already humidity in the atmosphere, so the drift will be comparatively less. All right. So you can go through the table which is given in the lecture. So I hope you will I didn't understand the criteria to select a particular irrigation system for a particular crop, soil, the place. Okay, so there's a lot of components are there and defined. So you can go through that. So the next student is Gajanana Satapa Mohite is a student. So his question was, sir, I'm very happy to learn your course. Will I use this course knowledge in my farming? Yeah, so this is a good question. So he's a student, as well as he wanted to, probably uh, develop his own farm or becoming a agripreneur, probably, or maybe he might be having farm, right? So the course basically talks about two things, right? One is irrigation, the other thing is the drainage. So in irrigation, so we discuss the basic information on the soil properties, soil water. Okay, so then the irrigation scheduling, right? So irrigation scheduling will include like when to irrigate, how much to irrigate, or how to irrigate. So these three things we already discussed. So in the farm, so right now you have to see what kind of irrigation system you are using first of all, and you have to understand based on the knowledge you gain from this subject. So whether the existing irrigation system is really fetching what you are deserving or what you are really looking for. So then the knowledge you gain from the course can be used in selecting a suitable irrigation system. Suppose if your existing irrigation system is not efficient, right? So now you know how to estimate the crop water requirement for a particular crop, right? So knowing the crop water requirement for a particular crop, you can decide how much irrigation we need to give during the irrigation season or the crop season, or when exactly you want to give an irrigation. So right now, I mean, as a farmer, so you may be having some traditional knowledge, right? So just to go to the field and shovel it and see the soil conditions, soil wetness. So based on that, your prayer, experience will tell you whether the irrigation is exactly needed or not. But scientifically, or what we follow here based on the soil water content. Okay, so for that, in order to know the soil water content, so you will have to use, different. We talked about different, methods to understand the when exactly required irrigation and how much irrigation is required and which irrigation system is needed to supply water. So all these things are very important, and the knowledge gained, in this course definitely will help you. Okay. Uh, so I think if you are seriously following this course, so I hope this will help you in giving irrigation efficiently, right? And the third is from faculty. I think she is Sahain. I don't know. So the student has a question. This is the technical question. So while the question was like, while explaining the concept of Darcy's Weisbach formula, it was mentioned as small FLV squared by 2ZD, but while solving the tutorial session, it was mentioned as 4FLV squared by 2ZD. Which one is correct? Yeah, so first of all, I apologize for the typographical error here. So in the first case, like small f l v squared by 2cd, so this is, you have to mention that like small f d l v squared by 2zd. So that small fd will be the friction factor. Okay, that's the friction factor. Whereas in the other formula, 4FL v squared by 2zd, so the small f here is friction coefficient or coefficient of friction. So the friction factor will be equal to 4 times of coefficient of friction. So that's simple substitution, right? So both are same. Only the terminology, I mean the acronym we used is wrong. So the first case, FLV square by 2CD case, it's a small fd. Okay, small fd. So that will be the friction um, factor. Whereas the second, 4FLV square by 2ZD, small f is friction coefficient. Okay, so then the next student, Akash Dwivedi. So he has no question. And Anup is a farmer, and he just wrote drip irrigation. But we don't know exactly his question is, what his question is. So he wants to know drip irrigation, or we don't know, maybe he will see the chat box a little later. And then the other student was like Abhinaya. So the question was like, what is the pattern of question paper? Whether it MCQs, and did they provide any scientific calculator to solve the problems? So I know you're, the first to attempt NPTEL. I mean, first time. So the question paper and the rules and regulations of the, the pattern, question paper pattern, all are available with NPTEL, right? So you can personally contact with them, right? So it's already available maybe in the website. You can go through that, okay? And then there is a Saktivel from Tamil Nadu. He has no question. Let me see, no question. And there is a Vibhuti is a student from Uttar Pradesh. So only this much, responses we got prior to the live session. So let me see whether we have any on chat box. So there is Aditya Kumar. Hello, good evening, sir. Yes, Aditya, good evening. Abhinaya, good evening. Okay, Abhinaya, good evening. So other than that, we don't have any questions from the chat box. We can just wait for few minutes and see if anyone asks some question. So otherwise, we can start, exploring something on irrigation and drainage course. What is that? Sir, I missed one assignment. What should I do? Sir, are we allowed to use calculator in the exam? All right. So whatever questions you're asking me, right? So that information is available on NPTEL website. For example, the question paper, pattern, right, and calculator, whether using of calculator in the exam is really allowed or not, right? All those things you can get from NPTEL office. So, because in case of assignments, because if you miss assignment, I don't know how it works. We give the assignments, or everything is looking, by the NPTEL office. All right. There is so Aditya Kumar. What sort of question can be asked? Whether any numerical or both theory and numericals? Okay, this I can tell you. Okay, what sort of questions? So the questions are mostly MCQ type, and it has both numerical as well as theory, right? And you must follow each and every slide in order to answer. And also your assignments are most important, because we expect more than 30-40% from assignments. Okay, so in the problem 12.4, why didn't we consider 2z in the equation? So let me go through that. Let me see. So, so 12.4. Okay, so it's Kumar is fine. Amana Abdullah. So I'll be back to your question. So, sir, irrigation methods taught in week 4 are a bit confusing. Formulas are very tough to remember. What should we do to remember the formulas? Who is that? Abhinaya. So, do you want me to give some tips on remembering the formulas? Right? So I think there are some simple ways to go through the step by steps. Then only you can remember the formulas. Remembering formulas may not give uh, good sense. So you will forget anyway. And even the exam, we don't consider right equations from somewhere. So that's okay. You have to remember some formulas like irrigation efficiencies, like sprinkler irrigation efficiency, drip irrigation, uniformity. So all these things, anyway, they are standard formulas you must remember. But the design problems, so you have to follow step by step, right? So irrigation methods, I know surface irrigation methods, there are a lot of design, steps, right? So the basic formulas you must remember could be, the volume balance. If you remember what is volume balance, what are the components, okay, what is the infiltration equation. So if you remember those, probably I don't think you will face any problem, right? Moreover, in the exam it's the MCQ type, and whatever problems you're solving in the assignments, so the mostly, you would see the similar kind of problems in the examination. So be prepared for your assignments and the slides, each and every slide. That's important, right? So any problem can be formulated based on the slide. Suggest any book of numerical irrigation drainage for gate. So that's a tough question. There are a number of books available exclusively gate agricultural engineering, right? So you can go through any numerical books, not a problem. But mostly we covered whatever the gate, the questions. So asked prayer, I think last 10 years. So we solved most of the gate problems, right? And the theory, so theory we followed could be sufficient, right, to answer your gate problems related to irrigation and drainage. So I hope, I think you need not be furious. If you are, really good at fundamentals, so no need of, opting any, book for solving the gate problems, right? I think in this course we covered most of the concepts required for answering the gate problems. Okay, so we have covered problems from irrigation, we have covered problems from tube wells and pumps, we have covered problems from drainage, right? So in addition to that, some advanced topics. So for if you're concerned, concerning the gate, so then most of the things we cover. So I think I should not miss this. Amana Abdullah, okay, 12.4. I'm just searching 12.4 problem. This is 13. So we'll go back. This is 8. Okay, so the next one is where I got a lot of numerical problems related with irrigation and drainage. Wow. If you want only numerical, see in the first class, like week 1, we suggested some books, isn't it? So if you're really interested in that, so you go through all the books. So there are number of books available in addition to that, but I prefer to follow those books. They are very good in getting the concepts and worked out problems. Okay, um, and also the short notes, or you can say they fill up the blanks and all other things. So it's a good, right? Uh, okay. Okay. I mean, if I summarize the whole course, whatever we learned till now, right? So I think we finished. It's now fifth week is going on. So the first week, we were talking about some introduction, along with some basic information on the structure of the course. So then the suggested books. Okay, so then irrigation. What is an irrigation? What is a drainage? Right. Okay, let me see. This is a week number 3, second.
Sir, you want to continue or shall I stop?
No, I'm just waiting for the responses.
Okay, okay, sir. Okay, sir.
So I think somebody is typing in between, right? All right. So I think there is Amana Abdullah in the problem 12.4. Why didn't we consider 2Z in the equation? So I think there is a mistake. So I think really, yeah. So we need to consider that. So we did not, somehow it is missing here, right? 5 by 4 d squared. So I was just checking. So FLV squared by 2ZD, right? So the 2Z is missing. So I think we have to correct that. Thank you. Thank you, Amana. So I think it's a time 5:50 p.m. So no, question from the audience. Probably we can off the session. Okay, so there is Abhinaya sir. Can you explain field capacity once clearly? All right. So the field capacity. So see, look at the term field capacity. The capacity of field, right? The capacity of field to hold the water, right? To hold the water. Suppose suppose you have a sponge. Sponge is like soil, right? You put a lot of water on top, right? Then after that, if you put some water, it absorbs. If you another little bit water, again it absorbs. Then after that, if you continually you're doing so, then there is a water which is coming out from the sponge, isn't it? So that water is called gravity water. So it comes freely. So all free water we can say. But don't add water on top. Just wait. So after some time, you observe the water flow from the sponge won't happen after some time, right? So then there is water which is hiding inside the pores of sponge. Okay. So if you can squeeze that completely, and you can quantify that water, so we can say that is the field capacity of the sponge. I mean the water at field capacity of the sponge. Okay, so similarly the soil. So if there is a rainfall, what happens? Water infiltrates down into the soil and fills all the soil pores. Okay, but some water, if the water is continuously infiltrating down, some water will escape through depercolation. Okay, so then if there is no water on top, I mean no rainfall, if it's stagnant, so what happens? So the water which is in the soil, will have enough opportunity to infiltrate. Then after that, depercolation will be zero after some time. And then whatever water which is present inside the soil pores after losing the gravity water, right? So that water we call the water at field capacity. Okay, so that is very important for the crops. Okay, crops easily can avail that water. That's the big. Okay, I hope you understand this. You welcome, Abhinaya. Thanks for asking, Amana. It's rightly you pointed, so we are going to, rectify that error. Good evening, Vikash.
Sir, no questions now, no questions. So shall I stop?
Yeah, yeah, we can stop.
Okay, sir. So please, sir, wait 15 seconds, then you can stop now.
So there is a chat box, Zoom, just to compute the size of the best quality cascaded file. But anyway, yeah, after 30 seconds, I'll stop. Vineet Chavan has a question. Sir, can you explain the irrigation phases? Once more, like storage and other phases. I don't know, do we have some time to explain? I'm asking the NPTL guys.
Yes, sir, you can continue.
Okay, all right. So this is Vineet Chavan's question. So he wants to know the irrigation phases, mostly in surface irrigation. Okay, so so the phases like from the starting from delivery of water at head end to stopping the irrigation. Okay, stopping the irrigation or irrigation after knowing that irrigation requirement is reached, and you turn off the pump. So on and off of the pump. So what are the phases we can explain right now? So first, when you just think about there is a furrow irrigation field, right? You turn on the pump and you turn on the valve at the head end of the field, right? So then your advanced phase started. Okay, so then slowly the water, runs into the furrow. So when it reaches the tail end of the furrow, right? So then your advance is going to off. I mean, you terminated. So your advance is going to finish. So, right? So advance is going to end. Then, so since the irrigation, requirement may not be, meeting, that means the soil may not be having enough wetness, or may not be the soil water may not be enough for the root zone, right? Or proper requirement. So in that case, what we do, we continue, uh, you know, delivering water or inputting water. So then, so then this your what you call the storage phase starts, because still there is a water on top, and during storage phase your runoff will start, right? So that is the starting of storage phase. So then once you understand that, okay, so after 1 hour, 2 hour, of giving water, this is sufficient, then we turn off the pump. Okay, so till the turn of the pump, your storage phase starts, ends, right? So when you turn off the valve at the head end, then your storage phase ends. So then from there onwards, your depletion phase starts. So the depletion phase, the identification of depletion phase starting, ending will be at the head end, remember. So the starting, when you turn off the pump, you turn off the valve, your depletion phase starts. So then what happened, you observe the water level, right? You observe the water level at the head end. So once the water level at the head end reaches to 0, then your depletion phase ends, right? And from that point onwards, your resistance phase starts. So the resistance phase is just an opposite to your advanced phase, right? So resistance phase means the drying phase. Advanced phase means wetting phase, right? Progressive wetting is the advanced, and progressive drying is resistant. So in the resistant phase, so when depletion ends, right, that means when the water depth at the head end is 0, your resistance starts, and then slowly when the time progresses, the drying phase is going to progress, and when it hits the tail end, right, then your resistance phase ends. Okay, I hope you understand this, right? But if you have more questions, you can email me, not a problem. Okay. Yeah, I think yeah, Vineet, I think I gave enough explanation. But if you need any anything more, you just email me. Okay. Yeah, I think we can end the session. So if you have more questions, we can see in the next live session. It's not a problem. Or you can email me. You can email to TS, right? We have Shashank and Swadika. So you can directly email to them, right? So we can reply to your questions. Not a problem. All right. Very good evening to all, and see you in the next live session. Take care.
Okay, sir. Please 30-second wait.